Hello everyone, very good evening to all of you. Welcome to PW Gulf. So today is the time for ultimate recap session of the chapter Friction. We have done this chapter in our classes and today is the time to revise it. So let's see what we'll be covering in today's class. We'll be covering what is friction, cause of friction, types of friction, then angle of friction, angle of repose, what these angles are, what their values are. We will be studying about contact force, the two components of contact force. Okay, so when two bodies come in contact, they exert a force, contact force. Okay, then we'll be studying work done in moving a body up an inclined plane. If the body is coming down on a rough inclined plane, what will be its acceleration? Okay, then we'll be studying circular turn on a leveled road, then banking of roads and bending of cyclists. Okay, so let's start our today's chapter. First is friction. So what is friction? Whenever we say that one body is moving over the surface of the other body, okay, whenever we say that one body is moving over the surface of the other body, we say that a force is exerted which opposes the motion of the body. Okay, but this statement is partially correct. Okay, till now we have always said that it is the force which opposes the motion. No, it is not the force which opposes the motion, it opposes the relative motion. When one body tries to slide over the surface of the other body, then the lower surface or the other surface will not allow the upper one to slide on it. Okay, it will exert a force to let not the upper body slide on its surface. That force is called friction. So what it opposes? It opposes relative motion, not motion. You will many times see that the frictional force is in the direction of motion of the body. Okay, so friction is the force which opposes relative motion, not motion. Always write the complete statement. So let us see the force which opposes the relative motion of two bodies in contact with each other is called frictional force. It opposes the relative slipping or tendency to slip. Okay, tendency of relative slipping between two contact surfaces. If we have a block and a surface like this, okay, now this surface is in rest, block will try to move forward, so this surface will not let the block move forward. It will exert a force on this block in backward direction, because if this surface doesn't want this block to slide, it will exert a force backward. Okay, so this force is called the frictional force. It opposes relative motion. It opposes relative motion. Now, what is the nature of frictional force? Okay, what is the nature of frictional force? We have four basic fundamental forces, and frictional force is electromagnetic in nature. Okay, frictional force is electromagnetic in nature. Now, because it is a force, SI unit of friction will be Newton. Okay, SI unit will be Newton. Dimensional formula for a frictional force will be again the same, MLT minus 2. MLT minus 2. What friction opposes? It opposes the relative motion. This is very important. You must know the difference between opposition to a motion and opposition to relative motion. Okay, so friction opposes relative motion. Now, what is the cause of friction? So if we have a block like this which is placed on a surface, to us this surface seems to be very smooth. Okay, for us this surface is very smooth, like this is a plain surface. But when we see the microscopic view of this surface, no surface is smooth. Okay, no surface is perfectly smooth. So there are there are abruptions on both the surface. Okay, there are some depressions, some raises on both the surface. No surface is perfectly smooth. They look like this when see under the microscopic view. So what happens, the contact is established at this point only. Okay, the contact is established at this points only, as the area of the points is very less. Area is very less. Now force is exerted. This body is exerting a force mg downwards, so force is exerted on these contact points only. So because our area is very less, pressure is large. Okay, pressure is very large. Now because pressure is large, there is bonding formed between the two surfaces. Okay, bonding is present between the two surfaces. Cold welds, we can also say that cold welds are formed, bonds are formed between the two surfaces. Now what happens, bonds try to keep the surfaces together. When we apply a force, the bonds, we try to break the bonds. Only if we apply a force which is greater than the strength of the bond, then only bond will break and body will move. So obviously there is a limit on friction. Okay, there is a limit on friction. Friction can have only a maximum value till the bond strength of the bonding between the two surfaces. Okay, now as we apply some force, we try to break the bonds. If we are applying lesser force, bonds will not break, body will not move. Okay, that's why we have seen that when we try to push a huge block or box, we push it but it doesn't move. We again push it, it doesn't move. Then we apply more and more force, and there comes a point when it slides forward. Okay, so till we apply a force greater than the strength of these bondings, then the bondings will break and body will move forward. Okay, so there is interlocking between these bondings, and that causes the friction. This is the cause of friction between two surfaces. So whenever two surfaces come very close to each other, okay, whenever two surfaces come very close to each other, what will happen, electrons of one, these are my two surfaces, there are atoms, so atoms of one interact with the other. In atoms there are electrons and nuclei, so there are electromagnetic interaction between the two surfaces. Okay, what is happening, there is electromagnetic interaction between the two surfaces. Now due to these electromagnetic interaction, the surface due to these electromagnetic interactions, there will be a net force between the two surfaces. If we have two surfaces, okay, there are atoms of both the surfaces, electrons and protons, electrons and nuclei of both the surfaces interact or repel with each other. Now in the attractions or repulsion, a net force is exerted on the body. Okay, a net force is exerted on the body like this. R, let us say this force is being exerted on the body. This R is called the contact force. This R is called the contact force. Why this force has come into play? Due to the interaction between the electromagnetic interactions between the two surfaces. Now if we resolve this force into two components, okay, if we resolve this force into two components, one will be perpendicular and one will be parallel to the plane. One will be perpendicular to the surfaces in contact, are perpendicular, and one will be parallel to the surfaces in contact. Okay, are perpendicular, it means perpendicular to the surfaces in contact, perpendicular to the surfaces in contact. This is called normal reaction. This is called normal reaction. Okay, the component of contact force perpendicular to the surfaces in contact is called the normal reaction, and the component parallel to the surfaces in contact, okay, component parallel to the surfaces in contact, this is called friction. This is called friction. Okay, so this R parallel is called friction. There are two components of the contact force. One is normal reaction. If this is my contact force R, there is one component which is perpendicular to the surfaces, that is called normal reaction, and there is one component which is parallel to the surfaces, which is called friction. Okay, one perpendicular and the other one is friction. So what we have is that R is equal to under root of n square plus f square plus 2nf cos of 90 degree. Cos of 90 degree, cos 90 is 0. So what we will have is R is equal to under root of n square plus f square. Okay, net contact force is equal to under root of n square plus f square. This is the contact force. Okay, this is the contact force. Now let us come to types of friction. So we have a block, okay, and a surface. Okay, we have a block and a surface. We are applying a force F on this block. Okay, we are applying a force F on this block. See, let us take the maximum opposition offered by bonding is equal to 10 Newton. Okay, let us take that the maximum opposition bond can offer is 10 Newton. Now if my F is greater than 10 Newton, if my F is less than 10 Newton, if my F is less than 10 Newton, what will happen? Body will not move. Body will not move because bond will not break, body will not move. So if we are applying a force of 6 Newton on a body forward, then body is not moving. It means there is a force of the same value in the backward direction, then only body will not move. If there is a force acting on a body in forward direction, then body will move forward. It means there is a backward force acting on the body, equal and opposite. Okay, equal and opposite. So friction will be 6 Newton. If I apply a force of 3 Newton forward, then frictional force will be 3 Newton backwards. Okay, see, maximum bond strength is 10 Newton. If we apply a force less than 10, body is not moving. It means there is a force which is acting opposite, and in magnitude it is equal to the force we have applied. So this is one type of friction which acts when the body is at rest. Now let us take that we apply a force of 10 Newton. Bond strength is at maximum peak. Okay, bond strength will be at its maximum peak. We have applied a force of 10 Newton. Bonding can offer a maximum opposition of 10 Newton. So frictional force will be 10 Newton. Now as soon as I apply a force greater than 10 Newton, okay, as soon as we apply a force greater than 10 Newton, what will happen? Bonds break. Bonds will break. Body will start moving. Bonds will break. Body will start moving. Now because body is in motion, there are abruptions on both the surfaces, but the abruptions are not able to make fully established bonds. Okay, now body is actually moving over the surface. So what is happening? Due to interlocking between the abruptions, we have a friction, but this friction is less than the static value. Okay, frictional force will decrease. Okay, frictional force will decrease. Why it will decrease? Because now the bonds are not able to form strong contact. Okay, strong bonding cannot be formed. One body is actually moving over the surface of the other body. So what will happen? Frictional force will reduce. Okay, frictional force will reduce. So from this we have two types of friction. We have two types of friction. One is static friction. One is static friction and the other is kinetic friction. Okay, other one is kinetic friction. In static friction, body tries to move over the surface of other. Okay, the frictional force which comes into place when one body tries to move over the surface of other body. Okay, when one body tries to move over the surface of other body, that frictional force is called static friction. And the force which acts when one body actually moves, when body actually moves over the surface of other body, moves over the surface of other body. Okay, the frictional force which comes into play when one body is moving over the surface of other is called kinetic friction, and one body is trying to move over the surface of other, that is static friction. In static friction, body will be at rest. Okay, body will be at rest. And static friction, there is no, it is not constant. It is not constant. The value of static friction is not constant. And in kinetic friction, body is in motion. Okay, body is in motion. Body is in motion and it has a constant value. It has a constant value. Why it has a constant value? Because then now the surfaces are exerting a average frictional force. Okay, it doesn't have the enough time to form the strong bondings. There is interlocking between the two surfaces, so there is a friction, but it has on an average it has a constant value. Okay, it has a constant value. So what happens? There are two types of friction. One is static and one is kinetic friction. So when body is not moving, that is the static one. When body is moving, that is the kinetic one. There is one more type called limiting friction. Limiting friction, when one body is just about to move. Okay, when just about to move, just about to move over the surface of the other body. When one body is just, like when we apply the force equal to the maximum opposition offered by the bondings, then the body is just at the verge. Opposition offered by bonding is 10 Newton. We have also applied 10. A little slightly greater force than 10 Newton will make the body in motion. So when it is just at the boundary condition, that value is called limiting friction. That value is called limiting friction. Now static friction is self adjustable. Okay, static friction is self adjustable force. Why self adjustable force? Because it adjusts itself. Okay, it adjusts itself. If you apply a force of 2 Newton, static friction will be 2 Newton. If you doesn't apply any force, frictional force will also be 0. If you apply a force of 3 Newtons, then static friction will be 3 Newtons. Okay, so it is adjusting itself according to what value you are applying. Okay, what value we are applying, it is adjusting according to itself. So that's why it is called self adjustable force. Okay, it is equal to applied force. It is equal to applied force. What force we are applying to make the body move forward, that much frictional force will be acting on the body due to the surface. Okay, it is equal to the applied force. It is self adjusting in nature. So which friction is self adjustable? Static friction is self adjustable. It doesn't have any constant value. Kinetic friction has a constant value, and kinetic friction will be little less than the limiting friction. Okay, because now the body has come into motion. So you see, when you try to push a very large block like box or sofa, first you need a more force. Okay, first you need a more force. Then once the body comes into motion, sofa or bed comes into motion, then you need a little lesser force. You will see that now it is a little easier to move the block as compared to earlier. Okay, so kinetic friction is less than limiting friction. Okay, kinetic friction is less than limiting friction. Kinetic friction is little less than limiting friction. Now let us draw a graph between the applied force and frictional force. Okay, so on this axis we have applied force, and on this axis we have frictional force. Okay, first, if you doesn't apply any force, frictional force will be 0. Then as you apply a force of 1 Newton, frictional force will be 1, 2, 2, 3, as till we reach the maximum value. Till we reach the maximum value, this is the limiting friction. Okay, this is the limiting friction. After reaching the maximum value, we notice that frictional force will reduce. Okay, after reaching the maximum value, we will notice that frictional force will reduce a little and it becomes a constant. This is called kinetic friction. This is static friction. Here static friction is acting. Static friction is equal to applied force. So 1 Newton, 1, 2, 2, 3, 3, 4, 4, till we reach a maximum value which is called the limiting friction. Okay, where one body is just at the verge of motion over the other body. Okay, we have applied the force equal to the maximum value of friction. Friction has a limit. Okay, it cannot keep on increasing. Bonding has a maximum strength. When we break that strength, friction will reduce. Okay, so as we apply a force, it will keep on increasing till the limiting value. That decides the limit of friction. Okay, maximum friction is the limiting friction. F maximum can be limiting friction. Then there is a little lesser friction which is equal to kinetic friction. Now the body is actually in motion over the surface of the other body. So now there is a constant friction force acting which is equal to kinetic friction. So this is the graph between applied force and frictional force. This is a very important. Okay, this graph is very important. Now let us see that frictional force will depend on frictional force will depend on what values? First, friction will only come into play if we have applied some force, okay? Until and unless there is no force applied, no friction will be acting. So necessary conditions for friction to act is there must be some applied force and there must be some roughness between the surfaces, okay? We should have a roughness and we should have a applied force. Now let us see. Friction depends upon, see, the bonding is formed at the joint points. More the downward force, this bonding is exerted on second, more will be the bond strength formed, okay? More will be the pressure, more strength will be of the cold welds. So what will happen? Normal reaction, okay? Normal reaction. More the force which is acting at the two surfaces, more pressure we are exerting on the downward surface, more stronger will be the bonds, okay? Next is nature of the two surfaces. Nature of the two surfaces. The two surfaces are smooth, rough, polished, of what material they are, okay? It depends upon the nature of the two surfaces. Friction doesn't depend upon area in contact unless and until normal reaction is remaining the same, okay? Now let us do laws of friction. So we have two laws of friction. First is law of limiting friction. Law of limiting friction. Now what does law of limiting friction says? That the value of limiting friction is directly proportional to the normal reaction. Law of limiting friction says that the limiting friction acting between two surfaces in contact is directly proportional to the normal reaction. So from here we will have FL is equal to mu S into N, okay? FL is equal to mu S into N, where mu is the proportionality constant called coefficient of static friction. Coefficient of static friction. Now mu will be equal to, mu S will be equal to FL by N. Now friction is also a force, normal reaction is also a force, so it has no units. It has no units and dimension. It is a dimensionless. It has no units and it is dimensionless, okay? It is dimensionless. So this is called law of limiting friction. The limiting friction is directly proportional to normal reaction. Then we have law of kinetic friction. Law of kinetic friction says that kinetic friction acting between two bodies in motion, or one body moves over the surface of the other, Fk is directly proportional to normal reaction, okay? It says that kinetic friction is also directly proportional to normal reaction. Remove the proportionality sign, we will get that Fk is equal to mu k times N, where mu k is the proportionality constant called coefficient of kinetic friction, okay? Mu k is called coefficient of kinetic friction. Coefficient of kinetic friction. And what will be the value of mu k? Mu k's value will be Fk by N. Now frictional is also same case, force divided by force, it will be dimensionless and unitless, okay? Now the mu k is little lesser than the mu S, that's why kinetic friction is little lesser than limiting friction, okay? That's why kinetic friction is little lesser than limiting friction, okay? Mu k is little lesser than mu S, that's why kinetic friction is little less than limiting friction. These are the laws of friction. Now let us move forward to angle of friction. Now what is angle of friction? We have a block which we have kept on a surface. Now we applied a force F. Due to this force F, there is a normal reaction acting upward and there is a frictional force acting along the surface. So a resultant contact force is acting on this block. Okay, a resultant contact force is acting on this block. What is angle of friction? The resultant of normal reaction and limiting friction. Okay, the resultant of normal reaction and limiting friction makes with the normal reaction. Okay, the angle which the resultant of limiting and normal, okay, limiting friction and normal reaction, that is R, resultant of normal reaction limiting friction makes with the normal reaction is called angle of friction. This theta is called angle of friction. This theta is called angle of friction. Now what is the value of this? So tan theta is equal to mu s, or theta is equal to tan inverse mu s. Okay, this is the value of angle of friction. We can calculate it. Apply tan theta. Tan theta will be perpendicular FL by N and we will get that as mu s. Okay, so theta is equal to tan inverse mu s. This is angle of friction. Now what is angle of repose? Suppose we have an inclined plane of inclination. Suppose we have an inclined plane of inclination theta and a body is kept over this incline. Okay, now see, if the incline is flat, now increase the inclination. Will body start sliding down at every angle? No, only at a particular angle body will start sliding down the plane. Only at a particular angle the body will start sliding down a plane. The minimum angle for which a body kept on it starts sliding down is called angle of repose. Okay, the minimum angle that an inclined plane makes with the horizontal when a body placed on it just begins to slide down is called angle of repose. So theta r, okay, theta will be angle of repose. Angle of repose when a body placed on it just begins to slide down, then it is called angle of repose. So value of angle of repose, tan theta is also equal to mu s. Both have the same value. Okay, angle of friction is equal to angle of repose. Angle of friction is equal to angle of repose. Sometime it is also denoted by theta r. Okay, so this is angle of repose. Now let us see acceleration of a body sliding down an inclined plane. So we have an inclined plane where theta is greater than angle of repose. Okay, theta is greater than angle of repose. We have a body which is kept over this plane. Draw the forces acting on this. There will be mg downwards, normal reaction upwards. Component of mg perpendicular to plane cos theta and along the plane mg sin theta. Now because mg sin theta, body has a tendency to move forward, so frictional force will be acting backwards. Okay, frictional force will be acting backwards. Now when body is moving forward with acceleration a, okay, body is slipping down with acceleration a, we know that normal reaction will be equal to mg cos theta. So what will be my value of friction? Kinetic friction will be acting on it. Value of kinetic friction will be mu k times n. So it will be mu k times mg cos theta. Now apply the Newton's laws of motion. Net force is equal to ma. Mg sin theta minus fk will be equal to ma. So from here mg sine theta minus frictional force will be mu k times mg cos theta is equal to ma. So m and m will get cancelled out. Acceleration will be equal to g will come out to be common minus mu k cos theta. Okay, this will be the acceleration of the body sliding down the inclined plane. Okay, this will be the acceleration of a body sliding down the inclined plane. Now let us see work done in moving a body up an inclined plane. So we have angle of inclination theta. To make a body move up an inclined plane, we have to apply some force F on it upwards. We have to apply some force F on it upwards. So what will happen? Frictional force will be acting downwards. Okay, frictional force will be acting downwards, and mg sine theta is also acting downwards. Okay, mg sine theta. Let us take the case when the body is just at the verge of motion. Okay, normal reaction, and opposite to this we have mg cos theta. Okay, so when body is just at the verge of motion, F will be equal to F plus mg sine theta. Just at the verge of motion, it means limiting friction will be acting on the body. So what we will have is applied force is equal to FL is equal to mu s times n plus mg sine theta. So it will be equal to mu s, n is equal to mg cos theta plus mg sine theta. Now for applied force will be mg comes out to be common mu s cos theta plus sine theta. Now this is the applied force. Work done is equal to F into S if F is the displacement. So from here we will get work done is equal to mgs into sine theta plus mu s cos theta. Okay, this will be the work done in moving the body up an inclined plane, where S is our displacement of the body up the plane. Okay, displacement of the body up the plane. This will be the work done in moving a body up an inclined plane. Now let us see circular turn on a leveled road. A body is trying to take a circular turn on a leveled road. We have a leveled road. Okay, we have a circular turn of a leveled road. If the radius of the turn, is r, see, there is a car which is taking this leveled turn. Draw the forces on the car. One force will be mg acting vertically downwards, weight of the car acting vertically downwards. One force will be normal reaction acting vertically upwards. Now as the car is taking the circular turn, it has a tendency to move outwards. Okay, so a frictional force will be acting inwards. Okay, a frictional force will be acting inwards. Now to make the body move in a circular path of radius r, we always need a centripetal force. Gravitational force and normal reaction are not along the center, so there must be a force which is giving us the centripetal force. And which force can act along the plane? Frictional force. Frictional force will provide us the necessary centripetal force. Okay, friction provides the necessary centripetal force. Okay, friction provides the necessary centripetal force. It means centripetal force will be equal to, if the body is moving with speed v on this curve of radius r, so frictional force, centripetal force will be mv square by r. This is equal to frictional force L. Now what can be the maximum value of this frictional force? We know that frictional force is always less than or equal to its limiting value, that is mu times n. Okay, mu s times n. Friction is always less than or equal to mu s times n. It means mv square by r. Friction is equal to the centripetal force, whatever friction is there, that is the centripetal force. So friction is equal to mv square r. It means we have a limit on the centripetal force as well. Centripetal force can't be greater than or equal to this. Now what is n? N will be equal to mg only. N will be equal to mg. Cancel the m and m. We will get that v square is always less than or equal to mu s times r g. Okay, this r will go into multiplication. So from here we will get that v should always be less than or equal to mu s into r g. Okay, this will be our condition. So what is the maximum value? V should be always less than or equal to, so maximum value is mu s into rg. This is the maximum value of the velocity of the body taking a turn on a circular road of leveled circular road of radius r. Okay, it can have a maximum speed of this, where mu s is the coefficient of static friction between the tires and the road. This is the maximum value we can have of the velocity of the car. Any speed greater than v maximum, any speed greater than v maximum, car will skid. Okay, car will skid. So we can only have a maximum speed. Okay, this is equal to mu s r g. This is the car taking a circular turn on a leveled road. Now this speed comes out to be very less, so we introduce the concept of banking of road. What we did is, with friction we added a component of the normal reaction. If we bank the road, then a component of normal reaction comes towards the center of the circular path, due to which centripetal force increases, hence the limit of the speed also increases. This is called banking of road. When we raise the outer edge of our road with respect to the inner edge by some height, okay, we tilt the road. This is called banking of road. The system of raising the outer edge of a curved road above its inner edge is called banking of road. The angle by which we have raised is called banking angle. Okay, angle of banking or banking angle. So if we have a road like this, what we did is, instead of horizontal, this road is raised by some height. Okay, this road is like this. Okay, road is like this, curved turn is like this. Okay, we raise the outer edge of the road with respect to inner edge by some height. We raise it by some height. This theta is called angle of banking. This theta is called angle of banking, and the circular turn will be like this. Okay, we have raised the outer edge by some height like this. Okay, you have seen in the race courses are car racing where happen, Formula 1 or like this, they are a little bit tilted. Okay, so this is called, phenomena is called banking of road. Now what happens in banking of road? See, if this is the angle by which we have banked our road, and there is a car on this, road. Okay, the circular turn of the road is like this. Okay, it has a radius r. Circular turn is having some radius r. Now draw the forces on this. We will have normal reaction n. We will have friction along the plane, and mg will be acting vertically downwards. Mg will be acting vertically downwards. Now if this angle is theta, this angle will also be theta. Resolve. We have f cos theta in this direction and f sin theta in this direction. Okay, if this angle is theta, then this angle will also be theta. Yes or no? This angle is theta, so this angle will also be theta. It means this angle will also be theta. Okay, this angle is theta, so component here will be n cos theta and here will be n sin theta. Now f cos theta plus n sin theta. F cos theta plus n sin theta provide us the necessary centripetal force. So they will be equal to mv square by r. Okay, r is the circular radius of this circular turn. Okay, r is the radius of this circular turn. Now n cos theta will be balanced by n cos theta will be balanced by f sin theta plus mg plus f sin theta. So from here we will get that n cos theta minus f sin theta is equal to mg. So name it as equation number 1, name it as equation number 2. Now divide 1 by 2. Divide 1 by 2. What we will get is f cos theta plus n sin theta divided by n cos theta minus f sin theta is equal to mv square by r into mg. So m and m gets cancelled. Friction, what will be value of friction? Friction will have the value mu times n. Okay, friction will have the value mu times n. Substitute the value mu n into cos theta plus n sin theta divided by n cos theta minus mu times n sin theta is equal to v square by rg. This is equal to v square by rg. Now take n cos theta common. Take n cos theta common, we will get that mu plus n is common, so there is no cos. Cos will come in denominator. Okay, similarly take n cos theta common from downside as well. We will get that 1 minus mu as it is, n common, there is no cos, so it will come in denominator is equal to v square by rg. This n cos theta gets cancelled, so we get mu plus sin theta by cos theta is tan theta divided by 1 minus mu times tan theta is equal to v square by rg. So from here we will get that v square is equal to rg into mu plus tan theta into divided by 1 minus mu tan theta. Okay, so from here we will get that this is the value of maximum speed when mu is equal to mu s, f is maximum, so this will be the value of maximum speed. Okay, this will be the value of maximum speed. With which the car can take the turn on a banked road. Okay, this is the maximum speed with which the car can take a turn on a banked road, okay, on a banked road. Now this is the maximum speed. So let us do a special case. If the there is no friction, okay, if it is perfectly smooth, if it is perfectly smooth, there is no friction between the tires and surface, mu will be 0. So what we will get is mu is 0. This factor becomes 0. Tan mu will become 0. We will left with only under root of rg tan theta, okay. We will left with only under root of rg tan theta. In this case, friction becomes 0. Only the component, okay, only the component friction becomes 0. N sin theta will provide us the necessary centripetal force, okay. So this is the case when friction is not present. So this is called banking of roads, and this is a speed when we have banked roads, and this is speed when we have banked road but with 0 friction. Now next is the bending of cyclist, okay. So when cyclist takes a circular turn, friction is not sufficient to provide the centripetal force. So what happens? The cyclist bends. A cyclist is taking a leveled circular turn. In a leveled circular turn, what we have? Friction provides the necessary centripetal force. But the friction between the tire of the cycle and the road is not sufficient. It is not of greater value, not sufficient to provide the necessary centripetal force. So what happens is the cyclist tilts itself towards the circular turn, okay, towards the center of the turn by some angle theta, so that a component of normal reaction provides the necessary centripetal force. So cyclist leans inwards because horizontal component of normal reaction provides the necessary centripetal force. So see, if cyclist is moving on a circular turn, what will happen? This is the horizontal. Let us take, this is the cycle, okay. Let us take, this is the tire of a cycle, okay. Now cyclist will lean the cycle. Oh sorry, I have leaned it on opposite side. Cyclist will lean its cycle towards some by some angle towards the center, okay. This is a cycle. So cyclist leans its cycle by some angle theta, by some angle theta. Now normal reaction will act along this line. Now normal reaction will act along this line, okay. So this is a cycle. Now normal reaction will be acting along this line, okay. This is a normal reaction, and mg will be acting vertically downwards. Mg is acting vertically downwards. Now draw the components. It has tilted its cycle by some angle theta. So what happened? There will be two components. There will be two components of the normal reaction. This will be n cos theta, and this component will be n sin theta. Now this n sin theta will provide us the necessary centripetal force, okay. N sin theta provides the necessary centripetal force. So n sin theta will be equal to mv square by r. If the cyclist is moving in a circular turn of radius r, okay, this will provide us the necessary centripetal force, and n cos theta will be balancing the weight mg. Divide the two equations, we will get that n sin theta divided by n cos theta will be equal to mv square by r by mg. M and m gets cancelled, n and n gets cancelled. What we have is tan theta is equal to v square by rg, okay. Tan theta is equal to v square by rg. So v square is equal to rg tan theta. So the speed with which cyclist can take the turn is rg tan theta. Okay, this is the speed with which the cyclist can take the turn when he leans inside in towards the center of the circle inwards by some angle theta. Okay, so that this normal reaction component of normal reaction provides us the necessary centripetal force. Okay, so this is bending of cyclist. Okay, so this is all about the chapter friction. We have revised all the topics. I hope this session was quite helpful. It has revised your the chapter in one snapshot. So keep studying, keep rocking. All the very best. Take care.